We are going to solve a lot of problems. Okay, you are all welcome to tonight's class. We are going to solve a lot of problems. I promise you in the morning that when I have time, I'm going to continue from where I stopped. And tonight, I want to continue from where I stopped. The questions is sent for me from ABU. These are past questions, distance learning, 2025. I think they just took the exam last, is it day before yesterday or thereabouts? Yeah. So we'll be looking at this past question. It says differentiate y equals 1 over sine x from first principle is simple as ABC. Is that clear? Please, I want you to like, comment, and share as long as you are here watching or following this class, and I'll be very grateful. Thank you. Okay, yeah, this is a very simple question. At first, let us write solution. We are to differentiate this function from first principle 1 all over as simple as ABC. From first principle, the formula is y plus dy equals to f of x plus dx. Amen? Okay. So if you agree with me, this implies that you know very well that if we are to differentiate functions like this from first principle, what I will advise you to do is compare this function with this. We have f of x plus dx. So if we want to write it this way, sine x, it means the constant here is your f. So it means your f is sine. Then your x here is this bracket. So instead of this x, we are going to replace it with this bracket. Is that clear? So now what we need to do here is as simple as ABC. That is, here will now be our y plus dy is equals to 1 all over, this is what, sine, this is your f, then your x is this bracket, open bracket, x plus dx. True or false? Do you agree with me? Look at it very well. Yeah. So I'm going to break it down for you. It's simple as ABC. Hope you are following. Okay. So what we need to do here is simple as ABC. Let's go back to our trig identities, compound angle. We know that if you have been given sine A cos B plus cos A sine B, true or false? Do you agree with me? Okay. So if you agree with me, then what if we now have sine, open bracket, x plus dx? This simply implies that this is the same thing as sine x cos dx, then plus cos x sine dx. Do you agree with me? Any question? So it implies that instead of this, this is what we are going to write. So take note of this. So this is simply means that our y plus dy is equals to 1 all over, instead of this we write sine x cos x, amen, plus cos x sine dx. Then, what are we going to do? We have to subtract y from both sides. So if you agree with me, it means y minus y, here will be 0, here will be dy is equals to sine x cos dx, then plus cos x sine dx, 1 over minus y. Then if I were you, put it inside the bracket. But what is our y? Our y has been given as well this. So it means here will now be dy is equals to sine x cos dx plus cos x sine, sorry, this is dx, right? Sine dx, amen. Then all over 1 minus y is 1 all over sine x, 1 all over sine x. Do you agree with me? Look at the question, look at the solving very well. Do you have any question? Please, if you have any question, drop it in the comment section. I'll be very grateful. Any question? No question. So now, at this point, excuse me, what we need to do, we have to look for the LCM of this and this. So the LCM of this and this is the product of this and this, two of us. So let's move further to consider the LCM. So it means our dy now equals to sine x, open brackets, sine x cos dx, then plus cos x sine dx, then because this divide this sine x, then this divide this divide this and this will cancel, we'll be left with this, but mind you, we have minus. So open bracket sine x cos dx plus cos x sine dx. Amen? Do you agree with me? Okay. So now at this point, what do we do? Let us have it in this form. So what we need to do here is we have to open this bracket. We write dy is equals to sine x minus, and this here will be minus sine x cos dx, amen. Then minus times plus, here will be minus cos x sine dx. Then all over, amen, all over sine, open bracket, sine, open bracket, sine x cos dx plus cos x sine dx. Do you agree with me? Any question? Please drop your question in the comment section. You agree with me, right? Okay. So if you agree with me, let's proceed. Let us proceed. So at this point, we are going to divide through by dx. So divide through by dx. So when we divide through by dx, it means this is what we are supposed to have. It means here will now be our dy all over dx is equals to sine x. Okay, yeah. Look at the board very well. Here we can factor out sine x to give us here 1 minus cos dx, then close bracket, then minus this here will be all over dx minus cos x sine dx all over what? Yes, right? Then all over sine x open bracket sine x cos dx plus cos x sine dx, right? Okay. So what we need to do here is here, look at it here. We introduce limits. Is that clear? When we introduce limits here, as limits, the x tends to 0, it means here will be 0, then here will be 1, because sine dx all over the x is 1. That is sine dx all over the x is 1. So here will be 1 times cos x minus cos x. Then anywhere we see dx, we substitute in this limit. So it means here, what we need to do here is here will now be our dy all over the x is equals to sine x open bracket 1 minus here will be cos x, true or false? Cos 0, right? Yeah. Do you agree with me? Then cos 0 is what? 1. So 1 minus 1 is okay. Cos 0 all over dx. Then here I've told you that sine dx all over dx is 1 times cos x minus cos x. Then all over here we write open bracket sine x sine cos here will be dx, right? So you substitute in this, so cos 0 is going to give you 1. So 1 times sine x is sine x. Then here will be cos 0. Here will be sine 0. Sine 0 is 0 times this. So I think this is how it will be. Yeah. So can you see now? So in other words, our dy all over the x is equals to, this is 0, true or false? So 0 times sine x is what? Is 0, right? Yeah. So here we are going to have what? Minus cos x all over sine x times sine x is sine square x. So this implies that if you use first principle to differentiate 1 over sine x, this is what you are supposed to have. dy all over dx is equals to minus cos x all over sine square what? X. But if you can see what I am saying, sine square x is the same thing as 1 minus cos square x. True or false? It's true. So that is that. So do you have any question before we proceed further? Please ask your question. Ask your question. Do you have any question? Yes or no? No question, right? Please, I want you to like, comment, and share, and I will be very grateful. So no question. So this is how you are going to approach this type of question. So if there is no question, let's proceed further to solve more examples, because there are many questions here. They sent to me, solve for them. Okay? So if there is no question, let's proceed to consider more examples. Okay. Yeah, let's look at another question. This one says evaluate integral 3dx all over 2x plus 3 is simple as ABC. When you come across functions like this, what you need to do here is you have to apply substitution. So you now say using substitution. Substitution method. Okay? So it means here you now say let any alphabet be equal to the denominator. Is that clear? But do you know that this is the same thing as 3 integral dx all over 2x plus 3. True or false? So we now use a substitution. So what we need to do here, we can now say let u be equal to what is here? 2x plus 3. So we have to differentiate this function with respect to what? X. So it means our du all over dx is equal to what? 2. Then make dx the subject of the formula. It means by the time you cross multiply, this multiply this, you are going to have du equals to 2 dx, then divide 2 by x. Now our dx is equals to du all over what? 2. So instead of dx, we substitute in what? Du all over 2. Then instead of this, we write what? U. Amen? So this implies that our 3 integral dx all over 2x plus 3 now be equals to, if you can see what I am saying, 3 integral, what is our dx? Yeah, our dx is du all over what? 2, right? So then what is our 2x plus 3 is u, right? So now what we need to do is 1 all over u times dx is du all over 2. So this is the same thing as we factor out 1 all over 2. So it means we are going to have 3 all over 2 integral 1 all over u times du. So if you integrate 1 all over u, it means you are going to have in. But here we have a constant, 3 all over 2. 3 all over 2 in u plus any constant, two of us. Yeah, but what is your u? Your u is this. So this implies that the final answer will now be 3 all over 2 in 2x plus 3 plus k. This is the final answer. Do you have any question on this? Please ask before we go ahead to solve more questions. These questions are from ABU Distance Learning. So please, if you have any question, ask. Any question? No question. So it means we can proceed, right, to solve more problems. Okay, it's simple as that. At least let's go ahead to solve more problems. Yeah, let's solve more problems. Here we have another question. I want to clean this. These are past questions from AB, Zaria. And all these things will help you. Please, I want you to like, comment, and share, not just watch. It will do you good and it will help somebody. Okay, one of the questions is evaluate the limit. Evaluate x limit x tends to 3x squared minus 9 all over x minus 3. It's a very simple question, and I want to tell us one thing about limit. Is that clear? Right solution. You know, limit, after substitution, limit does not want it to be answer 0 all over 0, no. It means this is undefined. Undefined. Yeah. Or, at the end of the day, maybe you solve to have 2 all over 0. Limit does not want it in this one. In this form, this is also undefined. Right? Do you agree with me? What limit want? Either 0 all over 3 or minus 1, or let me say 1, 2 all over 3. These are defined. So to avoid all this, one has to be careful while evaluating the limit. Let me just give you one clue. Supposing this is exam JAMB question. JAMB will give you 2 answers. Look at it. Look at it. And out of the 2 answers, one of them is the correct one. Just look at it. If we substitute this limit, x tends to 3, it means anywhere we see x, we write 3, right? But here, x carry 2 minus this all over 3 minus 3, right? So this implies that 3 raised to the power 2 is the same as what? 3 times 3, right? So here will be 9 minus 9 all over 3 minus 3. You can now see that 0 all over 0. And limits is trying to avoid this. But look at what I want to. It means, let us assume that in JAMB, A, 0 all over 0. Then B, let's just say, okay, B 6, then C minus 9. Let's see which one is the correct answer. So now what we need to do here is, since this is a perfect square, yeah, because this is an even number, true or false, then this is also a perfect square. And when you look at the operation between them is what? Is negative, right? So it means we can redefine this numerator because of this. This one, we can approach it using difference of what? 2 squared. Do you agree with me? Amen? Do you agree with me? Okay. So if you agree with me here, it means, note that, you need to write, note that x raised to power 2 minus 9 is the same thing as what? X minus 3, open bracket, x plus what? 3. Do you agree with me? Yeah. So it means, let's evaluate it. So we can now write limit x tends to what? 3. Instead of this, we write this x minus 3 close bracket x plus 3, then all over what? X minus 3. Can you see now? So as you can see now, this implies that this and this will cancel. True or false? So we are going to have limit x tends to 3, x plus 3. So let's substitute in the limit. So here will now be limit x tends to 3, x plus limit x tends to 3, 3. So this implies that anywhere you see x, you write 3. But if there is no x, it's just leave it like that. So can you see now, here will now be 3 plus 3. This is equals to what? 6. So can you see now? So supposing is jump want to confuse you. You will just go straight to, right, this is the correct answer. Why this is not the correct answer? This can never be the correct answer. The correct answer is this. So you have to be very careful. Is that clear? Although we are not solving jump questions, we are solving ABU distance learning past questions on Math105. Is that clear? So always take note. This is the right approach. Any question, please? Do you have any question? Please, I want you to like, share. Do you have any question? Yes or no? No question. Okay. So let's proceed to solve more problems. Differentiate with respect to x, the function. We have another question here. Differentiate with respect to the function. One of the questions says differentiate with respect to x, the function means y equals to exponential sine x. It's simple as ABC. In other words, They are asking you to find dy all over the x. It's simple. So what we need to do, we write solution, amen. So our y is equals to exponential sine x, right? So how do we differentiate this function? One, you can use substitution. Then the other one, you can use what? Direct approach, for the sake of time, so that it will not take your time. Is that clear? So if you want to apply direct approach, these are exponential functions. So what I will ask you to take note whenever you come across functions of this one, first consider what is here. What is here? Sine x. So assume that you are differentiating what? Sine x. So if you differentiate sine x, you are supposed to have cos x, true or false? So now this is the answer to this, true or false? So use this to multiply this function. That is all. So it means this we're going to give you dy all over the x is equal to, since we differentiated sine x to give you cos x, use it to multiply this function. It means cos x exponential what? Sine x. Do you agree with me? That is all. This is the answer. Is it difficult? Is it difficult? No. I don't think it's difficult. Please, friends, I want you to like, comment, and share. I will be grateful. Okay, so I think we have killed a question. So let us proceed further to consider another question. One of the questions says, find the derivative of 2x plus 3. Okay, I clean this. Find the derivative find the derivative of 2x plus 3 all over x minus 3 raised to the power of what? 2. Yeah. When they say find the derivative, we can now say let y be equals to this. So if y equals to this, 2x plus 3 all over x minus 3 all in what? Square. It means they are talking about your dy all over the x. But not necessarily you say let y equals to this. One can use p. So if it is p equals to this, you can get the p all over what? The x. That is the meaning of the derivative. One can say here t. Supposing here is t, if it means we have to find the t all over what? The x. So take note, when you come across questions like this, the derivative, you can use any alphabet to be equal to the function. Is that clear? Take note. Okay, so let's proceed further to going to explain it very well to your own understanding. So when you come across functions of this form, it's simple as ABC. If I were you, yeah, at first we have rules for differentiation, true or false. So when you come across functions like this, what will first come into your mind? You have to use what is called quotient rule, true or false. Using quotient rule, true or false. That is, it means quotient rule is of this form. y equals to uv, then our dy all over the x is equals to u dv all over the x minus v du all over what? Dx all over v squared. True or false? Yeah, you agree with me, right? Okay, so now what we need to do here, look at the denominator. The denominator here, we have x, minus 3, close bracket, only what? Square, isn't it? So what we need to do here is simple as ABC. You don't need a prophet to tell you. How? Is, if I were you, try to open this bracket. It means x minus 3 all in square is the same as x minus 3 times x minus 3. Can you see now? Do you agree with me? Please, look at the board very well. You agree with me, right? Okay. So if you agree with me, it means use this to multiply. You are going to have x squared. Use this to multiply minus 3x. Use this to multiply minus 3x. Minus 3 times minus 3, we have plus 9. So it means this is x squared. This plus this. Minus 6x plus 9. So the denominator will now be, it means we say let t equals to this. So it means, okay, let us use y. Amen. Okay. So it means our y equals to 2x plus 3 all over x minus 3 all in square is equals to, that is, this implies that this is the same thing as 2x plus 3 all over the denominator is what? X squared minus 6x plus 9. So we can now say, using this, we can now say, if you equate it with this, u all over v, you don't need the prophet to tell you. It means let your u be equals to 2x plus 3 and your v be equals to x squared minus 6x plus what? 9. So what you need to do is for you to what? Differentiate the function with respect to then substitute it into the formula. So we now let u be equals to 2x plus 3 and v be equals to x squared minus 6x plus 9. So what we need to do here is our du all over dx is equals to, if you differentiate 2x plus 3, you are going to have 2, and the v all over dx is equals to, if you differentiate this function, you are going to have 2x minus what? 6. True or false? So if you agree with me, you have to substitute this and this into this formula. So therefore, our dy all over the x is equals to, what is our ordinary u? Ordinary u is 2x plus 3. Then what is your ordinary v? The u all over dx, the v all over dx is this times 2x minus 6. Then what we have here, minus open brackets. What is your v? Ordinary v is this, x squared minus 6x plus 9. Then all over, what is our ordinary v? Okay, no, times du all over dx is 2, right? Times 2. Then v is x squared minus 6x plus 9 all in what? Square. So if you don't mind, you can leave it like this. But if you say you want to move further, no problem. Let's proceed. Let us proceed. Yeah. So far so good. If let's use this to multiply. Okay. So if this times this, we are going to have, it means, our dy all over the x is equals to 2x times 2x, 4x squared. 2x times minus 6 minus 12x. 3 times 2x is plus 6x. 3 times minus 6 is minus 18, right? Then here 2, we have minus here, so minus 2 multiply out this, use minus 2 to multiply out this bracket. Do you agree with me? So minus 2 times x squared minus 2x squared minus 2 times minus 6x plus 12x minus 2 times plus 9 minus what? 18. Then all over x squared minus 6x plus 9 all in what? Square. Amen? Okay? So if you can see what I am saying, this and this will go. Hope I did not commit any crime. Then what else again? 4x squared, it means our dy all over the x is equals to 4x squared minus 2x. We are going to have 2x squared, two of us. Then plus 16x minus 18 minus 18 minus 36. Then all over x squared minus 6x plus 9 raised to the power of 2. I think you can stop here. So, do you have any question? Please, if you have any question, ask. Let me attend to your question, then we proceed further to solve the other question. Do you have any question? Any question? Do you have any question? No question? So you mean we can proceed, right? Okay. Yeah. Another question says find y over dx by implicit differentiation of the function. Okay. Yeah. It says find dy all over the x by implicit differentiation of the function let me clean this, of the function 2xy then minus 4x squared plus y squared, right? Or y cubed, 4x y cubed equals to 3 cos 3x plus 2 is simple as ABC. What you need to do is, you don't need a prophet to tell you. So what you do, you write d all over the x, open bracket 2xy minus d all over the x, open bracket 4x squared, close bracket, plus d all over the x, open bracket y raised to the power of 3 equals to d all over the x, open bracket 3 cos x, then plus d all over the 2x, 2, sorry. What you need to do is here understand your product rule very well, I don't think you will have any problem. So his product rule we are going to apply. Since we have two functions here, x and y, just hold the two as what? Constant. Is that clear? So what? If we hold two constant, we either differentiate x or y, then any answer is to multiply the two constant, 2 and y. So already if you differentiate x, you're supposed to have 1, true or false? Yeah. So here, we differentiate x, we are supposed to have 1. So 1 times 2y, we are going to have 2y. The x, the reason why we are writing the x, it means we differentiated for what? X. Yeah. Then since what is the operation between them? Plus. In front of them, plus. So we write plus. First we differentiated x. So this time we are going to differentiate y. You can now see that we are using product rule. So if we differentiate y, we are going to have 1. This is to multiply 2x is 2x the what? The y. Why? Because we differentiated for what? Y. So all over what? X. Then that is that. We are done. What do we have here? How many functions here? It's just one. X. True or false? So we are going to differentiate it just once. So if we differentiate 4x squared, we are going to have 8x. Use it to multiply. What is here? Minus 8x. The what? The x. It means we differentiated for x. Then what do we have here? Plus. Then this is what? Y. So we'll differentiate only one function. Yeah. So if you differentiate y raised to power 3, we are going to have 3y squared. Use to multiply 3y squared. The what? The y. This means we differentiated for y. That is why you are saying the y all over the x. Then here equals to, come here, we have one function, 3 cos x, true or false? So 3 cos x, to differentiate cos x, you are supposed to have minus sine x, true or false? So now, since we have 3 cos x, it means you are going to have minus 3 sine x, the what? The x, all over the x. So this is a constant, 2 is a constant. So whenever you differentiate a constant, it gives you what? 0, true or false? Why? Because there is no variable attached to it, neither y or x. But supposing there is y here or x, we differentiate it. Exactly. So now you don't need a prophet to tell you. It means this and this will cancel, because just like 1 divide 1 or 2 divide 2, this and this will cancel. Then this and this will go. True or false? So now we collect like terms. Our 2y plus 2x dy all over dx, then minus 8x plus 3y squared dy all over dx is equals to minus 3 sine x. True or false? Do you agree with me? Look at the board very well. Any question? Do you have any question? Yes or no? Okay, no question. So this implies that this and this will move them to this side, then this and this will be on one side. So as you can see now, move this one to this side, then we are going to have this and this on the left hand side. It means 2x dy all over the x, then plus 3y squared dy all over the x. Then this will be equals to, take minus 8x to this side, we are going to have plus 8x minus 3 sine x. Then take plus 2y to the right hand side, we are going to have minus 2y, right? Okay, so now ask yourself what is common. The left hand side, dy is common because they say find dy over the x, so we have to factor it out. Dy all over the x is common, so we have 2x plus 3y squared equals to 8x minus 3 sine x minus 2y. So at this point, we have to find dy over the x. So what we need to do here is to divide 2 by 2x plus 3y squared. So therefore, our dy all over the x now equals to 8x minus 3 sine x minus 2y all over 2x plus 3y squared. This is what you are supposed to have. So, thank you for your time. We still have more questions. Series of questions from distance learning ABU, Zaria. I think tomorrow I will continue from where I stopped. Thank you for being with me. Please, I want you to like, comment, and share. Love you guys. Have a wonderful bed rest. See you guys again. Bye. In the morning. Yeah. Love you guys. Bye.